I think yeah, we are.
There we go. Cool. Yeah. So the concept of blockchains was not, we were just, before the break, we were talking
Yeah, we just
about,
welcome back everybody. We're listening to the recording. We just got back. So go ahead, Greg. We were talking about
how kind of like broken the method was for registering to become a certificate authority. And we were kind of knocking on that entire system for a little bit. And I was saying that, yeah, we can knock on it right now. But the truth is that at that point in time, that was the best we could essentially come up with. We didn't have the tools. The technology was not invented until Bitcoin came around and came up with the concept of proof of work consensus that gave us a decentralized consensus system that worked really, really well and was very, very secure. It just, the technology didn't exist before that.
Oh, absolutely. And ships used to go off. I always use shipping as an analogy because they were always uploading and downloading. Ships used to go out and have a weather report when they left, and then that's it. 6 weeks trip, you didn't get a weather report. But when the radio came out in 1912, you could do that. And whatever happened on the Titanic, 700 people lived because they had a radio. So they didn't have the technology before, but then from then on, it became a law. You're going to carry a radio. It's always going to be on. You're going to have 2 people on it.
Yeah, and I think one of the biggest hurdles that is facing the adoption of this technology for securing the internet is simply the lack of understanding and awareness. Right now, there is a lot of, let's just say, I don't know what's the best word to pick here, but there's a lot of hate pushed on a lot of tech websites towards blockchains and anything having to do with cryptocurrencies, which is a great shame. And I mean, I guess that's what happens when, money becomes involved in things, is that people get,
and it's not the way we did it when I was a kid. I always joke around with fire. AI to me, I always, that's my major obsession. I go, when I was a boy, we didn't cook meals. Let me tell you something. Then my father lived to be 23 years old. You kids with your fire. It's a fad. I hate it. I hate it. That burns things down. I can't stand the smell, and where are we? Would you want to go back to a time before fire?
Right. And one of the an upvoted post on it, for example, Hacker News recently, I saw, it kind of just blew my mind, but it said something along the lines of everything cryptocurrency related is a scam. And
there are actors. I saw an actor, the guy who played on whatever Batman, whatever Gotham, and he's all over the news. Actor says all cryptocurrency is a scam. I'm like, oh, thank you, actor from the Batman show.
Yeah, it's a real shame. And so what we need is, if people want a secure internet, it's available to them. The technology is now here. What is missing is more dialogue and conversation and understanding about how these systems work and why they're useful and why they, the fact that money is involved in these blockchains is actually a good thing, because now we have a system that has actual, it has economic security behind it, whereas before we didn't have that. So if a blockchain makes a mistake, there's a severe financial penalty to that entire system.
You can easily measure, that everybody can get. It's your
exactly that you can very easily measure. Exactly, yeah. We didn't have that before. These other systems, well, first of all, they're just fundamentally insecure. But if something went wrong, there's no like massive financial damage to these certificate authorities that happen. I mean, maybe fewer people start using it. Maybe there's a damage to that one certificate authority, but like there has to be a lot more. What's the word? There has to be a lot more care and attention to detail placed on the development of these blockchains. Development and software development for a while has been kind of like a Wild West, with people treating things in a Mark Zuckerberg kind of way of move fast and break things. And you can't have that if you want to design secure systems. And blockchains really put, an asterisk and an emphasis on that. Because if you try and move fast and break things in a blockchain world, a lot of people are going to be financially harmed by that. And so you just can't do that. And that's why, for example, the Bitcoin blockchain actually gets some heat for being too conservative and the developers too slow to adopt new features and things along those lines. And I think that if there is a disciplined community out there right now that has shown real good care and attention to detail and discipline for the art of programming, it is the cryptocurrency world, and not NFTs or anything like that, not the monkeys and the apes on Ethereum, but the Ethereum developers who work on Ethereum itself, and the Bitcoin developers who work on Bitcoin itself. Those guys know and understand that every single character and line of code that they write has to be perfect. And all of that code goes through lots and lots of rigorous testing before being released. And hopefully that culture continues forward so that there are no major explosions in the blockchain world. And so far there haven't been. The developers, at least for Bitcoin and Ethereum, have been doing a pretty great job of keeping these systems running securely. So let's go over some of these systems now. If I can share my screen, is that all right, Larry?
Yeah, absolutely. Please do.
Okay, so we were talking about Namecoin as being one of the first systems. I wonder if I can move this. Yeah, okay, good. So Namecoin was the very first fork of Bitcoin, and it added the feature of being able to register and own names. So it deserves a lot of props for being the first group and the first entity to push this concept. All of this started thanks to these guys, and they're still around. There's still several developers working on this project, and they've even received grants and funding to continue improving Namecoin, and they really understand this problem deeply. So I wouldn't count Namecoin out yet. A new
what's the yet? What?
The yet is that there are now competitors to Namecoin who have momentum behind them and have more people sort of excited.
But wouldn't it be part of your to keep multiple chains, let Namecoin be one of, and stay up, but also have the competition?
Yes. Yeah. Yes, exactly. But what I'm saying is that like a lot of people have forgotten about Namecoin. Larry, you said you didn't even know about Namecoin until this call.
I did not. Yeah,
but Namecoin is what started all of this, and so that's kind of what I mean is that like there's not much hype behind them, but oftentimes it's the projects that don't have hype because they're so busy and focused, nose to the grindstone, focusing on the technical aspects and the software development side of things that really should be paid attention to, while the others have maybe a little bit more, hype behind them because they're devoting more resources to promotion, etc. So, that's what I mean. I wouldn't count them out yet.
No, that's wonderful. And I feel embarrassed that I didn't know them before. And now it's going to go on YouTube that I do. I mean, no, I've known them for years.
Oh, no, don't feel bad. Don't feel bad. ENS. So the Ethereum name system is the same thing, except on Ethereum. Now, it's not entirely accurate to say it's the exact same thing because each one of these systems is slightly different in its own unique way. And usually the differences have to do with how you register names on these systems. So on Namecoin, it's first come, first serve. So there is no complicated algorithm as far, I mean, maybe they've changed things, but when I was involved in Namecoin and working on projects related to it, like DNS chain especially, it was simple. It was a very simple system. You had the same price for any name that you wanted. And that was actually one of the issues with Namecoin, is that because names were so cheap, including very valuable names, all of them were grabbed up. And there was a lot of name squatting going on Namecoin. Even I name squatted on some names. So, I stopped doing that. I don't do that anymore. But that's an interesting story in its own right. But ENS tried to address this by coming up with more sophisticated rules for how names are registered and pricing the names more appropriately. so that shorter names, for example, would cost more, and also having maybe a different way of registering the names involving an auction, things along those lines. So the Ethereum ENS started to pioneer and think about the problem of name squatting in a greater detail. So they deserve kudos and props for that too.
Greg, I'm just curious. I'm getting my head around, say, both of these, and are they already? If I register a name, Internet Network Defense dot whatever here, do I get a signing key as well, like a certificate?
Well, in order to register the name in the first place, you already need a key. So
I create my key pair, and then I get them to sign off on it, on my public key.
You create a key pair. So a name coin, it works exactly like Bitcoin. You have key pairs that you can create willy-nilly, and as long as those key pairs have name coin, the currency NMC associated with them, you can register names.
But when someone goes to my site and they get the lock or whatever, am I signing that with that key, or is it still patched with a standard X.509, some CA signed that?
Oh, okay. Well, the way that it should work is that it should go, the request from your browser goes directly to the blockchain and gets the latest key value pair mapping for that key, which is owned by you.
Right.
And the signature on the certificate that's received should be signed by your key.
Love it.
So that's how it's supposed to work. Now, how did they get the lock icon to appear in a browser? That might be a slightly technical detail. Like, for example, it could be the case that Namecoin installs a certificate in your browser that it uses to then a root certificate in your browser to then sign names locally after it has already performed that query and verified that you were the one who signed the thing with it. Like, I don't know, there could be some slight weird details, but the way that it's supposed to work is we really need to kind of throw out everything.
Ultimate high level is that I did it.
Yeah, exactly. It should be you. And that, in my opinion, is how it should be done technically as well. All of this data should just be signed and directly passed to you, and the lock icon should be there saying that it was signed by a key that was registered on the blockchain, and that this connection has been verified essentially by Namecoin itself, because it is the Namecoin blockchain that is responsible for
doing
managing
the ultimate, that your private key can, or your public key can be trusted because we trust you.
Right, exactly. Because we trust the entire Namecoin blockchain, we trust all of the keys within it.
I got it.
And that mapping. And because the Namecoin blockchain is being built through this expensive process of proof of work, which is, I mean, this talk isn't about how proof of work works, but proof of work works very well. It is a genius. It's slow. Yeah, I mean, it can be slow. It can be somewhat fast. Like Ethereum used to be proof of work, and blocks were minted once every 12 seconds or something like that. In Bitcoin, it was once every 10 minutes, but you can make that faster. There are ways of making proof of work pretty fast and making the blockchain grow at a fast rate. So in Ethereum, it was once every 12 seconds. In other proof of work blockchains, it's faster than on Bitcoin, which is once every 10 minutes. I don't remember what Namecoin was. It might be the same as Bitcoin.
It looks like they're following Bitcoin's white paper anyway. So are they using the same size salts and difficulty level? That's different.
Yeah.
Okay.
And then there's Handshake. So right, we talked about Ethereum name service or system, and then we get to Handshake. Handshake is a newcomer to the scene, and they have a whole lot of momentum behind them because they're doing quite a lot of interesting, just really smart when it comes to building an ecosystem around themselves. So one of the things that they did that was kind of brilliant was they created a bunch of this, they pre-mined effectively a whole bunch of HNS, the tokens, and they gave it to like all of the users on GitHub. They just looked on GitHub to see which users had keys registered with their accounts. And they gave all of those users HNS. And if you have a key, an SSH key or a GPG key associated with your GitHub account, I can't remember it, right here, claim HNS for free open source software developers. That's one way. Like, they're really good about giving their token away to people. So that was one thing that they did. They also gave away a bunch of HNS to certain companies that had to do with registering names, like, for example, Cloudflare and Namecheap or something like that. I don't remember all of the names of the companies that they gave them to, but they kind of incentivized financially a bunch of these companies to adopt their system by giving them free HNS. So this is what I mean by like they're playing the politics of this very well, whereas the other systems didn't even think to do that. Now, the actual blockchain itself is implemented, as far as I can tell, it's a fork of Bitcoin or something like that, which is a JavaScript version of Bitcoin. So HNS is a proof of work blockchain that is a fork of JavaScript implementation of Bitcoin.
So it still uses the miners. It still
uses the miners and all that stuff. Yeah, no proof of stake silliness here. I kind of I don't want to say a bad word on YouTube, but I disparage. I kind of disparage proof of stake sometimes, even though proof of stake, it's okay. It's got its place. It definitely has its place, and there's specific good ways of using proof of stake. And I'm a little bit sometimes skeptical of using proof of stake as the consensus algorithm for the main chain, because it has some security properties that are not as great as proof of work. Totally separate.
To put it simply, but I'll tell you what, I'm gonna.
And it's also way more complicated. When you and I were talking about it giving us headaches to read about proof of stake, it's way more complicated.
No, and then add in sharding. So here's where I come from, Greg. Working up that stack the way we did as a wirehead, we'd start realizing, we got all these different networks to get to, and they're constantly changing, and routing protocols come out, and RIP and OSPF and stuff. And Cisco comes up with a concept in the 90s in their routing protocol. Don't let every router keep a same copy of basically the Bitcoin blockchain or whatever. If it were that, it's like, we don't need it. You just don't tell people stuff they don't need to know. So, at a very simple connection, if you normally send things to me to get to the internet, and I normally send it to Bob, but one day I'm going to send it to Alice, do I need to tell you? No, you still send it to me. And most routing protocols do that. They're like, hey, everybody, there's a change. And they're like, oh, does that affect me? No, but I want you to know it. And so Cisco was so great at pruning out the unnecessary information in a mesh of networks, but it's not blockchain signed. And I've been saying for years, I wish you could get the people who developed Cisco's EIGRP in a room with the people who developed Bitcoin, and come out with a sharded proof of work network that scales.
That would be pretty cool. Yeah, sharding for proof of work has not been done yet, as far as I know.
No.
Although there are attempts to now do that. One attempt is called Drive Chain, which is an attempt to introduce effectively sharding to Bitcoin. And there are different ways of doing sharding with proof of work, and that is one way. And it does not have the same security properties as Bitcoin itself. It's slightly weaker security than Bitcoin itself. So it'd be really cool if somebody could come up with a way to do proof of work sharding that is as secure as the main blockchain itself.
Well, we still use the term convergence. So here's an example of convergence, which we see here, but we've been dealing with this in the 90s. If there's a change in a standard, in the old days, it was OSPF, now everybody's BGP. But if it was OSPF network, and so it's up to 50 seconds before everybody realizes, oh, there was a change. And you're not sending anything as you're recalculating this. In Cisco, it's like 5 seconds. And it's like, that's so, because you don't need to tell everybody everything. Yeah. So anyway, so we would see a better conversion. I don't know the Bitcoin I want to mess with. I want to keep it as it is. I want to just take other stuff, borrowing that where the use case makes sense. I think for money, I like Bitcoin just as it is. I don't want to touch.
Yeah. So by the way, I don't know if your students are, if they can ask us questions or if they have any questions, but if they do, I'd be happy to answer any questions. I can also go into this this HNS presentation on Handshake if there are no questions.
Yeah, guys, I'm watching the chat box, so if anybody has a question, I will pay attention to that now. Otherwise, go on, and I'll let you know if somebody comes in with something.
Okay, cool. So, this is a talk that was given by Matthew Zipkin about Handshake, and we'll just quickly go over it ourselves because it's a pretty good talk. As far, I don't think I actually saw the actual talk, but I looked at the slides and they were good. Oh, okay, this is the end of the slides. Okay, let me go all the way back to the front. Right. So, what is DNS? And this is, I guess, this is a nice way to kind of end or wrap up this call with an overview. It takes name and gives an IP address, and there's a root zone. That's the root DNS servers, and they delegate to a top-level domain, the .com, which then delegates to individual owners who buy names under .com. And then if those owners have any subdomains underneath the domain that they bought, those are called subdomains. This kind of shows which machines are queried in this whole process. And this entire process is, as I mentioned in my talk, completely insecure. Yeah, so it goes through that. What is the structure of DNS? This gives a nice little visual structure. I didn't have this in my talk, and I thought it'd be nice to visualize this, that it is kind of like a tree. Oh, the root zone. Okay, so this is a YouTube video where they actually recorded the signing ceremony for the root zone key or the whatever, how this works. DNSSEC has a very elaborate and very complicated signing ceremony that they use, and like the way that they have these computers in specific rooms and you're only allowed to go there. It's kind of like a James Bond thing where certain members and individuals have certain like key cards or something like that, or keys they're supposed to turn at the same time to unlock the secret vault. And then they get like the computer from the 1970s or 80s that's like been there, and its sole purpose is to sign these keys. It's insane what they end up having to do. And you either trust them that they have performed this ceremony properly, or you are skeptical and you think that this is all security theater, that it's kind of like a magician basically. That's effectively, and that's the camp that I'm in, is that this ceremony is really more of a magical performance, and when the cameras are like are off, or when you're not looking somewhere, like you really have to trust that they performed this correctly, this ceremony correctly, and there's no trickery going on behind the scenes. That's really what they're relying on.
But if they use big words and stuff and they dress nice, they got suits on and stuff.
Right, exactly.
Powdered wigs. Let's give them a powdered wig.
and that's kind of how the security of the system works. I'm not a fan of it because I prefer systems that are just kind of like designed well, and from a mathematical perspective are designed to be secure from the get-go and don't require robes and wizard hats and ceremonies to be secure. So, okay, this talks a little bit about DNSSEC, how the different keys that are involved. So there's a key for the root zone, there's a key for the .com that's managed by the entities, and the key for a key that your computer is supposed to have to sign these updates, and then et cetera, et cetera. So yeah. And then here they talk about what is a certificate authority. We've already gone over that. Internet security, DNSSEC. And then this shows how these two systems are separate. That's kind of like what I was talking about.
And let's pause on that, because I didn't stop that. I knew these things, but I didn't stop and think about how stupid this is. Look at this, guys. We all know what that DNS works, and is that the the hierarchical database of X.500 names, and that CAs are a hierarchical system of trust with keys. Why aren't they the same?
Right. And when you introduce this type of unnecessary complexity with all of these different systems and all of these different keys, you introduce places where something can go wrong.
Yeah.
And secure systems are supposed to be simple systems. The best systems in terms of security are ones that are simple. And that's another thing that I really don't like about proof of stake, is that proof of stake is insanely complicated. And it's not just complicated from a theoretical and conceptual point of view, it's also insanely complicated from an implementation point of view, because the theoretical and conceptual point of view is complicated. The amount of code that is needed to verify a proof of stake blockchain is on the order of probably like 100 to 1,000 times greater than a proof of work blockchain, which can be verified very, very simply, and the code written for it very simply. So it doesn't, nobody really needs to like trust that, the code was written correctly.
Only because Tom is here, and Tom is the most chat GPT enabled person I know. I'm wondering if we're not getting to that point where I can throw it to chat GPT or somebody, go, does this look good to you? Can you come up with a better proof of stake?
Right. Yeah. Chat GPT. Throw that question to Chat GPT, see what it has to say. I hope people are using their own heads these days and not relying on not outsourcing their thinking to Chat GPT. How does an HNS query work? So here we have at the center this chain. That's the blockchain. That's the root zone is the blockchain, and then we have the same IP being returned and signed from the person who registered the name. So as you can see, this is simple. Like just conceptually, this is way more simple. Like the blockchain part, of course, you have to expand it, and you've got proof of work behind there, but it's one system. Whereas, here it's insane. And you've got robes and wizard hats doing secret ceremonies or public ceremonies, et cetera.
The basic principle of fewer parts to break. It's so much better. It's so much better.
Okay, so here, I'm not entirely sure what he's talking about here. Dane, by the way, is a specific, you guys might, I don't know.
I know a little bit. And it's really just a basic, this is what I started talking for my students. This is SP 1800, not 800. And it's it's what really the NSA or NIST wants us to do for securing email. It's a great idea. Try making it work. So you use DNS to make sure that your servers are, you're resolving right to the right server, and nobody's doing it. And when they do it, it doesn't work, as we pointed out. The one part that is working mostly is we have TLS between our MTAs, and then we're supposed to have SMIME on our workstations. And you tell me, if you're not in the DoD, when was the last time you got an SMIME email? And the answer is you never did. So
Dane is a standard or an RFC for a specific type of
DNSSEC implementation.
But also it talks about a specific type of DNS record type. I don't remember the name of the record type, but it might be right there. I think it's TLSA. That might be the name of the record type. Actually, that is the name of the record type. Pretty sure.
Oh, yeah. Okay.
So Dane specifies a specific kind of DNS record. Now, I don't even know what this is doing on their slides. I'd love to hear the audio version of this, because Dane is not secure, because the Dane record itself is not signed by anything.
This is so funny. Guys, what this is going on is that they're giving a certificate to sign the DNS records. And again, CCSP guys, that's called the anchor key. This anchor key is not trusted by the browser. So they're like, I don't even know who you are. So I guess we got to tofu it. Trust on person.
Yeah, so maybe there's a way for this record, it might be the case that this record could be used as part of the machinery for DNSSEC in some way, and that those keys are trusted. So that might be how it works. But by itself, it's not secure. You need something else in addition to it to secure it. So how can I resolve HNS names? HST full node built-in resolve. Okay, so this is okay. And here they're talking about the SPV node. So that's what I was talking about earlier with the light clients. They're also known as thin clients. That is a way for the connection to be verified as secure to the blockchain, that for the results from the blockchain to be verified that they're secure in a way without you having to download the entire blockchain yourself and verify the whole thing. So that's the difference between a full node and a light client. The reason why it's called light is it's kind of like diet soda. You're not getting the entire blockchain. You're not having to wade through, gigabytes of data that needs to be downloaded and painstakingly verified. A thin client can do it very quickly by just downloading the headers of the blockchain and using Merkle proofs to verify that the results are correct. So if you're interested in how that works, I actually recommend reading the original Bitcoin white paper.
Is that a typo? Must request Urkel tree? It's Merkle, right? It's around Merkle, or is there something as like a UR
Urkel tree proofs? I don't know. It's something they come up with really interesting names in the blockchain world. It's like Vitalik came up with something called uncled blocks. These are blocks that don't make it as part of like the main chain, but they're kind of like orphaned, but they're not entirely orphaned off of the chain. There's still like a percentage of them. If a miner mines an uncled block, they still get a percentage of. Anyways, the names that these people come up with are crazy. So I can't tell you for sure that this isn't a thing. There might be an
It's real.
proof.
No, it's real. There really is a handshake protocol called the Urkel tree, and it's on GitHub at handshake.org.
There you go. Okay, so that might be a specific type of Merkle tree proof for all I know. I don't know exactly what that is, but it's probably, I'm guessing, a specific kind, or maybe a more efficient version of a Merkle tree proof. And Merkle trees are very simple. They don't take long to understand. So you can like read the wiki page on that. And also, if you're interested in this stuff, the very first place to start with blockchains in general is the original Bitcoin white paper. Read that because it's one of the best white papers that has ever been published by humanity. It is so simple, so elegant, so concise. It's only 9 pages long, and each page has a visual explanation of what it's talking about. It's beautiful. Check it out.
And one of the things on there, guys, that Greg, I can tell you have a grasp of it, is that you've talked about a few of these basic, I don't care who you're talking, I don't care what kind of technology, and the Byzantine general problem is a very important thing, no matter what technology you use, and how do you trust anything? And I get so many people, yeah, but what's the one place I can go to that I can trust? And that's the whole problem.
Yeah. So this talks a little bit about how to actually resolve HNS names, whether you're doing the resolving with DNS over HTTPS or DNS over TLS, or you're querying actual DNS servers. So, this slide, I assume, is not telling, this is kind of like for developers or people or enthusiasts, because this is not going to be, this is not the DPKI dream. In DPKI, we're not telling people to use DNS servers to resolve blockchain names. We're not saying that. We're saying you can use a completely different system, and specifically, you could be using thin clients to do the resolution, which talk to the blockchain network directly. That's the best way of doing it. And then the second best way of doing that would be something like DNS over TLS with a pinned certificate for that specific server. So, this concept would be like a browser ships with, let's say, 20 different DNS servers that are running full nodes. And it has pinned in them the public keys for those nodes. And then it queries, say, to keep it decentralized, 2 of those nodes and makes sure that the responses it gets from both of them match. And that is another way of doing it. It's a generalized way of doing it if, for example, a blockchain does not implement a thin client for doing resolution. But the thin client is the most correct way of doing it.
So let me back up. I am kind of sluggish sometimes, especially when I get caught up in one idea. So for me to truly take advantage of, say, I'm going to use Chrome or whatever, and I want to connect to a blockchain-based name resolution system, I could just go DNS over TLS and pin some so-called, it looks like a DNS connection to them, but I'm not actually DNS because it's over TLS. I could do whatever, the backend could do whatever it wants. But that's really a retrofit to Chrome. It would be ideal if either Chrome had a plugin or something, or build in a way to just put in the blockchain resolver. Would that make, is that?
Yeah, the thin client is what would be the ideal, that the browser, and actually not even the browser, what would be the real ideal would be for the operating system itself, because the operating systems have a network stack, right?
Right, and they get a DNS entry right there.
Yeah, and operating systems need to resolve names all the time.
Sure.
Yeah, so the ideal would be for the operating system to ship with a thin client that everything else queries.
Just goes right through, of course, of course.
Yeah. Now, the politics of this and the way that, you know, all of this is moving so slowly might mean that maybe browsers will start shipping it first.
Yeah, but that's a patch. Yeah, right. And that's just a retrofit until we get it working.
Right, and that's a patch, because what that means is that only the connections that your browser is making to those specific blockchain-based TLDs will be secure. All of the other connections your machine is making are not secure. And that's why we like to really solve this problem. You need to get it in at the operating system level.
Yeah, I could see a kernel level driver that just plugs into your IP stack, you know, and just do it right there, the way whatever.
Yes, that would be a solution. Yes, and a kernel extension would be maybe the way to go. So and also the libraries that ship. You know, if you're a developer, you're having to deal with lots of like the libopenSSL or libSSL or libcrypto and all that. That's where OpenSSL lives, and OpenSSL is often the client-side library code that has the X509 code, verification code in it, that's responsible for verifying X509 certificates and communicates with the system's trust store of all its certificate authorities to do all of that stuff. That's oftentimes a library. So, but yeah, both the library and the kernel extension may be like it's not easy. This is why this is taking so long, is it kind of requires a lot of you know,
yeah, I guess because
resources to implement.
The problem is you're doing two things at once. Like I'm sitting there going, no, that should be pretty easy to just change DNS, but you're doing more. You have to do the cryptographic check at the kernel level. And right now, DNS is assigned at kernel, but and you could override it in that, but the cryptographic checks are actually done at the application layer. They're done too high up the stack right now.
Yeah, and I mean, I don't, you know, I'm not telling operating system developers how to do their job. They don't necessarily need to have this be a kernel extension. It could be done entirely in user namespace. Like even the kernel could reach out to a user namespace daemon that does this stuff, or you know, there's different ways for this to happen, but there needs to be something below the browser that does this for the ideal solution. So, and that's kind of like where this is coming, like, you know, where is DNS? DNS is like on your local machine, there's a DNS client, right? And that's a daemon that is responsible for talking to a DNS server, et cetera. So, but again, this is not secure. Like, how do I resolve? Like, yes, you could do HNS resolution insecurely through DNS. This is one way to do it. So, and then this talks about how names, like, I don't even understand what this slide is for the first part, the 52-week rollout thing, I don't quite understand. But the reserved names, they've gone ahead and reserved certain names so that people cannot register them because they don't want to, they want their blockchain to be adopted, and they don't want to affect big companies like Apple, Google, Facebook, et cetera, by allowing some random person to register Facebook's name or Apple's name, you know, and then own that trademark. So that's why, you know, they've done this in a very mature way, I have to say. So this is why HNS is pretty promising, because they've thought about things like this, you know, whereas other blockchains haven't. For example, Namecoin did not pre-register trademark names. Anybody could register apple.bit.
I remember when the whole thing came out, my boss had registered his family name, and I mean, this is 93 or something. I'm like, greenblatt.com is taken, and one guy in Canada owned like 500 different people's last names.
Yeah.
And he wanted me to buy it.
Yeah. Okay, how are HNS coins distributed? Massive airdrop to open source software community. That's what I was talking about before. It looks like they did it to both SSH and PGP keys. Hacker News users with PGP keys on Keybase. That's right, they did some Keybase stuff. Subsidies added to certain reserve.
Can we stop right there? That's one
Yeah.
of my favorite. So I'm really into the email thing, and so Hacker News users. What are they saying? There is a key. What is Keybase? This is another chain.
No, Keybase is a messenger. It's a secure messenger. It's an end-to-end encrypted messenger.
I see. Okay.
Yeah. And you can register a username on Keybase. And what they're saying is that if you are a Hacker News user, because on Keybase you can say that you can prove that you are a certain person through other websites. So if you register a username on Keybase, you can say that I am the person who also registered this name on Hacker News, and you can link the two accounts together. And that's what they're talking about here, is that if you registered a name on Keybase and you linked your Hacker News account to it, then to your Keybase PGP key, we sent you some free HNS.
Okay.
That's what they're saying. And there's a way to claim it. So again, this is really smart because it's going to financially incentivize people to get on board with Handshake. How do I get a name on HNS? Covenants. I don't really understand any of this because I haven't taken time to understand it. But if you're interested, this is a slide, and I'm sure there's a presentation somewhere that you can watch where they explain how this works.
No, I could see it. It's just basically vetting your domain name or something.
Yeah. There's some kind of an auction system for doing this. So they've clearly taken inspiration from the ENS developers. And how do I get a name on HNS? There's a website called namebase.io that you can go to register these names. And I'm sure there's other ways of doing it too. For example, you could probably just run an HNS node and buy HNS somewhere and then do it yourself locally. And you can then become that could be a whole business that you do is, I'm going to be a registrar for names on HNS, and that's the business that you run.
Oh, wow.
Yeah. To make it easier for people who don't want to run full nodes. How do I get a name on HNS? So there's some kind of I don't know. Okay, questions. Yeah. So, and then here's some links that you can visit to if you're interested in HNS. I think this is a great place to kind of to end this. I think we've been talking for a while. I'm happy to answer any questions though, or
well, people,
thoughts.
I think the people who are watching just enjoy it. Tom found the Urkel tree. It's an optimized and cryptographic provable key value store for decentralized naming. So it's a Merkle tree, just especially because you could say that Bitcoin is an implementation of a Merkle tree. It's one. And then there are whatever NoSQL servers that have another implementation. So Urkel tree is specifically a Merkle tree for naming. So it sounds really cool.
Yeah. Very cool.
This is awesome. This is awesome because again, Greg, I just go over and over. To give you a little bit about my background. I grew up in the neighborhood in North Philly, poor kid, and I'm a street kid, and we're always laughing at one of my favorite things. I have students tell me that they were I changed their life with this. I'm always looking for how something could go wrong. So when Pay at the Pump came out, it's like, would you like a receipt? And I'm going, well, if you're going to ask me, yeah, because for all I know, you're going, if no, add 10 cents. So I just sit there. How could you mess somebody up with that? In fact, when I did that talk at Shark Fest, that was my yeah, but you could mess somebody up with that. And I just sit there and go, look, if you don't know who you're talking to, I don't care how good your security controls are. If you think you're talking to the boss and it's the attacker, you'll hold the door for him. Doesn't really matter. Yep. So this is the biggest challenge. And the other thing is it's going the other way. What do we protect more than anything? What we identify with. And I say, if I get my ID card from say my driver's license from the DMV in Harrisburg, if that gets compromised, do they suffer? No, I have the most to lose from that. So protection of your identity, to me, is the ultimate thing on the internet. It's the ultimate thing. And get it wrong, nothing else matters, And so this is, and as you pointed out, right now, it's not working. It's very vulnerable.
Yeah,
very brittle. Now it does work. It's just that we don't know. There's a difference between stealing my car and stealing my social security number. If you steal my car, I don't have it. You steal my social security number, I might not even notice it. Right? A man in the middle, I don't even notice that you're sitting there watching everything. So it's not.
Honestly, it's remarkable that the internet hasn't exploded yet, to be honest.
And I had one guy tell me years ago, because of routing, I say it's great at failure, but it's not, it's not secure like blockchain. No, it's not. And it'd be really easy, relatively easy to break all of the routers on the internet. So I said that in 2005, a guy, and he goes, we're all waiting too, because BGP, the Border Gateway Protocol, is the most important thing. Dude, it's so easy to break because of what you pointed out. So, and he goes, all we can figure is the hackers don't want to break their playground. So it's kind of like I had the NSA. People from Fort Meade explained to me, he said, do you know how, this back in the day, terrorist networks, he goes, do you know how hard it is for us to find good network admins? Where do you think Al-Qaeda is? Their admins suck. We break into their networks to patch them. Because if they go down, we can't see what they're up to. So
that's hilarious.
The reason it stays up is because people want to see. There's no value. I want to know what you know, and there's dead men tell no tales, right?
Yeah,
got to keep you alive and talking. No, this is great, man. This is great. Anybody else got any questions? I'm just I don't want to. I very, very much appreciate you making up the time here. Tom says, "What about unique blockchain? What about a unique blockchain for name resolution?" Well, that looks like what did you just show? What was it? HMS? What was it called?
Yeah, I mean that's what all of these are.
Yeah, they are. Tom.
Handshake, Namecoin, and Ethereum. Well, Ethereum is not a unique blockchain for just doing name resolution. They do all kinds of things, including pictures of monkeys. But Handshake is dedicated to the subject of name resolution, and Namecoin is also dedicated to
now,
this
is Handshake,
idea.
are they the same one as HDNS.io? Is that also them?
I think so. Yeah, I think the thing that you were talking about with HDNS.io is the same thing as Handshake. HDNS.io. Let's see what this is. Handshake DNS, access the decentralized internet on any device, is a DNS resolver for Handshake websites that, okay, yeah, so this is, what this is essentially DNS chain is what this sounds like. I worked on a project called DNS chain. This sounds, which is, it pairs a DNS resolver with a blockchain so that for programs that use the DNS protocol, they can do the name IP address mapping using a blockchain by talking to a DNS server. So, if like locally, for example, on your local area network, you have a trusted DNS server that you can query, that connection to the DNS server is insecure on your local network. If it's it could be man in the middle as well. But you could add something to it like DNS crypt. With a DNS server and with Handshake, that would be a secure system. So this is a DNS server paired that's designed to be paired with a blockchain. That's what my understanding of this is.
One of the things I always need to point out to my students, especially, but the general public doesn't get. Encryption, the word crypt comes from the Greek. It means to hide. Blockchain is not built to hide anything. If Bob and Alice are the only two people with the keys to the safe, they don't just get to hide stuff. If Alice opens up the safe and sees something she didn't put in there, it came from Bob. This is how we know who people are. And so I like to say, we talk about, Greg, my students have to memorize the CIA triad. You must protect confidentiality, integrity, and availability. And I say confidentiality is like saying, hey, can this guy keep a secret? But integrity is like, hey, is this guy lying on his resume? And it's much more important that things are true. And blockchain, it doesn't hide what you do. It proves that, I like to say, are we hiding the peanut butter, making sure no one knows where it is? Or are we making sure the peanut butter wasn't damaged in shipping and it really did come from Skippy? And so that's what this is supposed to do. And a lot of like DNS over HTTPS or whatever, those things are not to validate who somebody is. It's just to make sure that no one can see who you're looking up. I don't care if you see that I'm looking up YouTube. I want to make sure that it is YouTube I'm going to. I mean,
Yeah.
maybe I care, but more important to me is that it is YouTube. Sometimes
so
keeping secrets important, but
Tom also asks, they all seem to have coins involved, so can we make money by generating traffic? I don't know what you mean by generating traffic. Maybe you could clarify, Tom. But they all do have coins involved, and they all need to have coins involved because that is the way that these systems are secured. If they don't have coins involved, then then they become way more centralized. So you could, for example, have a consensus system that has some computers together using a consensus protocol, talking to each other, and then you query those computers for whatever they agreed upon. Those are called BFTs, I mean, Byzantine fault tolerant. There are protocols specifically to that called Byzantine fault tolerant consensus protocols. And the problem with those is that they're centralized. There is somebody who is deciding which computers are part of that system. There's a single entity that it makes that decision. And therefore, you have a centralized consensus system, and that's no different than just effective. That's conceptually the same as having a single computer. You're just going to some guy effectively and saying, "Hey, what do you think this name should be, mapped to?" And there's no difference between that, and therefore that guy that you're going to is the one who actually owns your name.
yeah,
That's why it doesn't
you don't
work
solve
for
the
the
root problem. You don't solve
Yeah.
the root problem. Yeah.
That system is not capable of giving people ownership of their names. That's why we need a decentralized consensus system. And the decentralized consensus systems, they use these tokens to incentivize people to mine them in order to perform their duty while remaining decentralized, meaning allowing other participants to join into the system and also become miners. So that's why the tokens are there. They're really critical to the security of those systems.
But there's no financial incentivization of being a miner.
There is a financial incentive of being a miner with these blockchains. That's the tokens that you can then sell on the market.
Oh, okay. So there is. So that's what your Tom was. So can we?
No, Tom is actually talking
by
about
generating traffic. Yeah,
he's talking about like ads generate income, SEO. I don't know what you mean, Tom, by that. I have no idea. So I can't answer that.
Tom, I've known for over 40 years, and he can figure out a business out of anything.
Maybe
the first
he
guy I
means
know to
like,
have a computer.
Yeah, maybe he means running ads for HNS. I honestly don't know what he means, so I can't. No, I don't know.
No, I'm wondering if maybe saying that the more users on this network, the more whatever people can see a billboard somewhere. I don't know. Yeah, Tom says neither do I. He didn't know where he was going.
Yeah.
God bless you. That's how imagination should be, right? You're allowed to imagine whatever, but then come back to reality.
Yeah.
I always say we balance our imagination, our memory. I like to imagine, hey, I wonder what else I could burn. But I remember, oh, don't burn hand. That was a bad idea. Remember last time I put hand in fire? Don't do that. Learn from history, but keep your imagination open. Greg, I don't want to keep you any longer. Thank you so much. I'm going to pause the recording, but pause, or I'll just